Hi students, welcome to my lectures on chemical reaction engineering. In the last class, we have discussed about analytical method of finding volume of a CSTR for liquid phase reactions and gas phase reactions. Today, let us attempt to find out volume of a CSTR through graphical method. For example, you have the conversion data and rate data. That means some people have conducted some experiments in a batch reactor. From the batch reactor, you have got the data that if 0% conversion, what is the speed of reaction or rate of reaction? If 10% conversion, what is the rate of reaction? 80% conversion, what is the rate of reaction? You have this data with you. Now, using this data, you have to find out what is the volume of CSTR at maybe for 50% conversion. Let us do that. Given, what is given? We know the conversion data and rate data. This comes from the different experiments conducted in a batch reactor. Now, let us use this data to find out the volume of the reactor. If you remember this equation in the last class, volume of the CSTR is nothing but Fa0 by minus Ra into X. Okay, Fa0 by minus Ra into X. Now, let us divide this into two terms. One is Fa0 by minus Ra and second term is X. Now, the volume is nothing but a product of these two terms. Let us assume the product is y into x. Y is Fa0 into minus Xa, x is nothing but small x. If remember, if you area of the rectangle or area of the square, it is nothing but length into breadth. It is just like if you want to find out the volume, you have to multiply length into breadth. What is the length is nothing but my y axis, small x nothing but my length of the x axis. Then if you example for 50% conversion, this is my data. That means if I plot the data Fa0 by minus Ra on the y axis, on the x axis x, that means this. Okay, I know Fa0, this is my reactor, and I want to maintain the flow rate of 1.5 mole per second. This is what I wanted to pump my reactants into the reactor at the molar flow rate of 1.5 mole per second. I know 1.5 mole per second and I know minus Ra data, multiply example Fa0 by minus Ra, just a second. This is Fa0, I know Ra, I know 1 by minus Ra, I know Fa0 by minus Ra. If I do that, I get the x data and Fa0 by minus Ra data. Okay. Then I have some data points. Through these data points, I can connect a line to all the data points. That is what this is, the black line. Now, I have to find out the volume of the reactor using this graph. I know volume of the reactor is nothing but y into x. For 50% conversion, I have to find out. That means draw a straight line at 50% conversion, and wherever you meet the curve, draw a horizontal line. Okay. Then you can the area of this rectangle is nothing but volume of the reactor, because volume is nothing but product of these two terms. You cannot calculate the area under the curve because there is no integration here. Whenever there is an integration symbol is there, then only you have to take out area under the curve. There is no integration in this equation. So, the volume is nothing but area of this rectangle. That means if you know, draw a straight line and connect a horizontal line, and whatever the area of this complete box, nothing but the volume of the CSTR. and because if you plot a graph and this this length comes to be around 9, Fa0 minus Ra, that means this length is 9 and this length is anyway, it is 50% conversion, that is 0.5. If you multiply 9 into 0.5, example, this is the 9, example, this is the 9. Yes, this 9 into 0.5 is nothing but the volume. Here 4.5 liters, okay. Because the units of rate in mole per liter, per second kind of. So the unit of the rate is mole per liter into second, okay, and the units of Fa0 is moles per second. So in general, you will get the volume unit is in liters. That means for 50% conversion, you need to have the volume is around 4.5, okay. 4.5 liter reactor is required, and if you know the volume, you can calculate the volumetric flow rate, because whatever exercise we are doing, it is for the liquid phase reaction. We know for the liquid phase reaction for the first order, example, this is the first order equation, V0, nu 0 is nothing but V into K into 1 minus x by x. If you know K, the conversion is again 0.5, because we have estimated the volume for 50% conversion, and you can V0, once you know nu 0, tau space time, volume by volumetric flow rate, initial concentration you will get, okay, final concentration you will get, because this is a liquid phase reaction, nu 0 equal to nu, final volumetric flow rate is equal to initial volumetric flow rate. That means you can get all the data for the reactor if you have the data. That means Fa0 by minus Ra versus x. Through this you can able to find out the volume required for given conversion. Example, if you wanted to know the volume of the CSTR for 70% conversion, it is nothing but at 0.7, that means at 0.7 on the x axis, draw a straight line, wherever it meets, draw a horizontal line. Now wherever it meets the point, you need to mark that length and this length, okay. Now the entire area of rectangle is nothing but the volume for the 70% conversion. Volume for 70% conversion is nothing but, now you have to count this bigger rectangle, okay. Once you get the volume, similarly you can use these formulas to find out volumetric flow rate, space time, initial concentration, final concentration, all the data whatever you want, you require to design the reactor. I hope now you understand what is the graphical method of finding out the volume of the continuous stirrer tank reactor. Thank you. Let us meet with the new reactor.